So we're going to factor these three trinomials. So here we got 25 and 10. This is good practice for the test. So that's going to give us 5 and 5. So if they ask for factors, we could do x plus 5 times x plus 5. Or more efficient way is x plus 5 squared. Okay. Let's go ahead and do the second one. 9 and negative 6 are the sum and the product and the sum. Negative 3, negative 3. So that's going to be x take away 3 times x minus 3. Or a more efficient way is x minus 3 squared. Okay. You got to put a little more into the last one. This is one where we definitely have to do, let's see, 9 times 4, that's 36. And the sum is going to be 12. 6 and 6. So let's go ahead and do this. We've got 9x squared, 6x, another 6x, and 4. And let's see. What can we factor out of 9x squared and 6x? 3x. And then what can I factor out of 6x and 4? So 2. And so then we've got 3x times something is 9x squared. And then let's see, 3x times something is 6x? 2. Yeah, because 2 times 2 is the 4 that we want there. So we get 3x plus 2 times 3x plus 2. And since it's 3x plus 2 times 3x plus 2, can I just write it as 3x plus 2 squared? So what do we notice about the factors of each of the polynomials, and how do the factors compare to the original polynomial? We want to make that connection, because we just saw an example of squared binomial or perfect square trinomials. So think about this. Is there any connection between x squared and 25 and then the x and the 5? Or the x squared and the 9 and the x and the 3? How about 9x squared and 4 and 3x and 2? Reduced by how? What's the connection between 9x squared and 3x? Half of the power. Remember we call that square rooting? Yeah, it's a square root. So maybe we could say, well, what do we want to say? It involves power, squared numbers, and square roots. I'll say squared values, because sometimes we have variables, and that's a value that we're squaring. And their square roots. So this is going to lead us to talk about perfect square trinomials. We already talked about these when we multiplied these. So a perfect square trinomial is a result of squaring a binomial and will have one of the following formats. Write the factors below each trinomial. So say we have a trinomial that follows this format: a squared plus 2 times ab plus b squared. Well, when we factor it, like we just saw, we're going to get the square root of a squared, which is just a, and because there's a plus sign here, get this. Because we have an addition sign there, it's going to be plus the square root of b squared, which is b, times the same thing, times itself. So it's going to be a plus b times a plus b, which can be more efficiently written as a plus b squared. So if it's a trinomial that follows this pattern, it's just a plus b squared. Now if we have a minus sign, it'll be minus b. And that's what we did in this example number 2 up here. We had a minus, so that's what we did there. So it would be a take away b times a take away b. And since we're multiplying something times itself, it's a minus b squared. So what we want to do today is kind of look out for this pattern. Because if we recognize it, we don't have to make that box. We don't have to do any of the X problem, any of that stuff. If you recognize it, you basically figure out what are the square roots, and either you add them together and square them or subtract them and square them. Okay? So let's go ahead and look out, check what to look out for. So the question below can help you determine if a polynomial is a perfect square polynomial. Okay? So this is what we're going to look out for to see if it's a perfect square trinomial, one of these basically. And so what we want to do is see if are the first and last terms perfect squares. If so, list the square roots. So we're going to look for that. Are the first and last terms perfect squares? And if they are, we're going to find their square roots. Okay, so now we move on to part 2. Is the middle term twice the product of the square root found in step 1? Okay, this is a mouthful. Twice the product of the square roots. And if the answer is yes to 1 and 2, the trinomial is a perfect square trinomial. So let's test this out. So what we're going to do next is we want to just check. We have A through D, A, B, C, D. So we have 4 trinomials. And we want to see, are these perfect square trinomials? So let's start with A. Okay. We got 4x squared for the first term, 25 for the last term. Well, let's see. 4x squared. Is that a perfect square? Yeah, it is a perfect square. So that one's good. Then 25, is 25 a perfect square? Okay, so now right above, let's just write down their square roots. So the square root of 4x squared is 2x. The square root of 25 is 5. Okay, so now the first part checks off. We're good so far. Now let's check the middle, this one. Is the middle term twice the product of the square root? Okay, so twice the product of the square roots of step 1. So basically 2 times 2x times 5. Does all of this equal 10? What's 2x times 5? 10x. What's 10x times 2? 20x. So is what we have here 20x? No. So we would have to say, is it yes, it checks off as 1, or no, it doesn't? It doesn't. We needed this to be 20x. Okay. Well, let's try another one. Let's try B. Is x squared a perfect square?
Yes.
Yes, it is. Is 81 a perfect square?
Yes.
Yes. Okay, so let's square root them and write those over here. The square root of x squared is 1x. So I'll just write it as x. The square root of 81 is 9. So now we want 2 times x times 9. X times 9 is 9x. 9x times 2 is 18x. This one does check off. So B is one of these. 2 times the product of those square roots did turn out to be the middle term. Okay? Let's try the next one. 2x squared. The problem is the 2. That number, that coefficient has to be a perfect square. 1, 4, 9, 16, 25, 36, 49. It has to be one of those type of numbers, right? The problem was here. Right away, we figured it out. Yep, the 2 kind of threw us off. 144 is good, right? The square root of 144 is 12. That's a perfect square. So that would have been good, but that kind of threw us off. So C is a no. Okay, try the last one. Try the last one. I'll give you a little bit of time. Okay, so this is what I got. 16x squared is a perfect square and its square root is 4x. 9 is a perfect square and its square root is 3. So now we want to test it out. We want 2 times 4x times 3. So 4x times 3 is 12x. 12x times 2 is 24x. So this one does check out. So D is a perfect square trinomial. Okay. So the first thing is recognizing when we have them. And when we do have them, factoring is going to be easy because guess what? I see a plus sign here. I know the square root of the first term. I know the square root of this term. The answer will be 4x plus 3 squared. If I have to factor it, it's 4x plus 3 squared. Any questions? Let's start factoring then. And one of the reasons I like the notes here is this is going to be a very, very, very good checklist for us because this is everything we need to look out for when we have to factor completely. So if you're keeping this for your notes, especially on the test, you want to make sure you cover all of these as we're factoring. So it says perfect square trinomials are another special structure to look for in order to help you factor. Review and consider each of the steps in the following checklist before factoring the polynomials in 1 through 4. Okay, so let's start with number 1. Josue, can you read number 1 for us?
Is there a GCF that can be factored out?
Okay, that will always be your first thing to look for. Is there something you can factor out? Either a number or numbers and variable that you can factor out. Okay, that's the first thing. And we have to go in this order. Number 2, is there a polynomial in any of the forms below? Okay, so this is basically where we have x squared plus bx plus c. What we have here, ladies and gentlemen, is where a equals 1. So remember what we do there? We just use the x problem, right? C and b. So that's the quick one. Ax squared plus bx plus c is when a is greater than 1. So unfortunately, we can't just use the x problem straight up. What do we have to do? AC. And then you have to use the box. That's how we factor those. So obviously, this is quicker. This is a little more work. And then we have the 2 others that we learned, those special cases. When was it that we talked about this Friday? Difference of squares. So is it a difference of squares? If it is, it's quick and easy to factor those. Okay? Those are going to be a plus b times a minus b. And then is it a perfect square trinomial, the ones we're talking about now? And that would be a plus b squared or a minus b squared. So basically, this is a checklist of all the things we can factor. All right, let's factor. So let's begin. Can I factor out a GCF from number 1? Nope. No GCF. So let's see. Can I use this method? I could. Let's check and see if it fits the perfect square trinomial first, though. Because x squared, is that a perfect square? 169, is that a perfect square? Yeah, it's 13 times 13. So we have x is a square root there. 13 is a square root there. Is this fit the pattern 2 times x times 13? Yeah. X times 13 is 13x. 13x times 2 is, so basically we have x, will it be a plus or a minus? Plus. X plus 13 squared. Or you could say x plus 13 times x plus 13. Okay. Any questions? So we didn't have to do any diamond problem, any of that stuff. Just recognized it as a perfect square trinomial. Okay. Let's do the next one. We've got 25x squared minus 60x plus 30. Is there a greatest common factor I could take out of all of this? No. Well, 5 goes into these 2, but it doesn't go into the last one. 6 goes into these 2, but not into that one. So no. So here's our options. Either we do this method, which we're going to deal with some mighty big numbers, or we pray and hope that it's a perfect square trinomial. Let's see. What's the square root of 25x squared? 5x. It is a perfect square then. What's the square root of 36? 6. So then we're going to check 2 times 5x times 6. 30x times 2, which is, yeah, you put the sign. This is where the difference. So here, because of this plus, this became plus. Because of this minus, guess what's going to go in between the binomial? The minus. So we're still good. This is going to be a minus here. And what's our first term? 5x minus 6 squared. Okay? All right. So let's try this one. So we've got x squared. Well, first of all, is there a GCF I could take out? No, we got 29 and 100, and x's aren't in everything. So x squared, its square root is x. 100, its square root is 10. So we want 2 times x times 10, which would be 20x. X times 10 is 10x, times 2 is 20x. We got 29x. So it didn't fit that. Guess what we have to do then? Well, not the longest. It's the one that's 100 here and negative 29 here. We got to do that. Since it didn't fit the pattern where we could do it the quickest way, this is the second quickest way. Negative 25. Wow, that was quick. Negative 25 and negative 4. Yeah, these work out. They multiply to a positive 100 and they add up to negative 29. So then we would get x take away 25 times x minus 4. Yeah, if we multiply these, we'll get that. All right. So now we have 9x squared minus 42x plus 49. Is there a GCF?
No.
No GCF? Okay. I was hoping we would get a GCF, make this smaller. 9x squared, that's a perfect square though, isn't it?
Yes.
3x.
49 is not.
Yes.
Sure it is, 7 times 7.
Oh, yeah.
Yeah. And then we want 2 times 3x times 7. Yeah, that's 21 times 2, which is 42. And we have the minus. So we get a squared binomial with a minus here. 3x here and 7 there. 3x minus 7 squared. Okay. All right. Any questions? All right. So let's try this. Mrs. Carter writes the following perfect square trinomial on the board, but the middle term got erased. Declan. The name's Declan. Have you ever heard anyone by a name Declan? No, me neither. Claims the middle term must be 16x. Okay. So is that going to be the right term?
Yeah.
Well, let's try it out. Won't know till we try it. What's the square root of x squared? X. I'll write it down here. Square root of 64 is 8. So we want 8x times 2, which is 60. Okay. Is that the only option? 16x, meaning positive or negative. So I think it's a little iffy because he didn't say plus or minus. It could be plus or minus, right? It could be plus or minus. So I think what we better say is sort of. Technically, I guess he's wrong. Has to be either plus 16x or minus 16x. And that'll make a big difference. It has to be one or the other. Okay. So Rebecca is making square pot holders for family Christmas presents. The area of the pot holder is 144x squared plus 96x plus 16. Write an expression to represent the sides. So this is the area. We want to figure out the sides. Another way of asking us to factor this. So they're asking us to factor this. Does it fit our pattern for perfect square trinomials? Yeah. This is 12x. Oh, didn't even catch that. And 16 square root is 4. And then this would be 2 times 48x, which is 96. So what's going to be our answer here? Each side is what?
12x plus 4 squared.
So each side is 12x plus 4. 12x plus 4, since it's a square, each side has to be equal. So 12x plus 4 times 12x plus 4. Okay. So here's the challenge for you. Write a perfect square that includes the term 36x squared. And you can use plus or minus. I'll use plus. So figure out, my recommendation is figure out a perfect square that goes here. Has to be a perfect square. And then from there you can figure out the middle part. But it has to start 36x squared. Okay? So try that out. I'll let you try it. Check with your partners. Check with your table partner. Okay? So based on what I picked, this would be 6x plus 5 squared. Okay? Okay. So for the last part, draw a line for each of these. What do we have? We're going to connect these together. And I guess it's going to be either a perfect square trinomial, neither or a difference of two squares. So let's see here. 4x squared minus 25. Well, it's not a trinomial, so it's a difference of two squares. This is what we learned Friday, guys. So what would the answer be here? Yeah. The square root of 4x squared is 2x. Square root of 25 is 5. So it's 2x minus 5 times 2x plus 5. Okay. Let's try this one. 4x squared minus 20x plus 25. Yeah, that is a perfect square. 4x, well, that's 2x and 5. 10x times 2 is 20x. So this would be which one? Yeah, 2x minus 5 squared. Okay. The last one, let's see. This is a perfect square. That's a perfect square, but this would have to be 20x, right? You just saw that. So this is a neither. So it has to be something else that multiplies to give us that. And just because we're pressed for time, it's this one. If I multiply these together, if I were to do the x problem in the box, I would get this answer. Okay? All right. So today's assignment is an IXL where we're factoring all kinds of stuff.